I was thinking of making this a short course in SolidWorks, but looking at the Chapter 4 projects, 4.1 through 94, that doesn't seem very short. So we're going to take it in chunks of 3 or 4 here and kind of go through. There are some repeat items that we'll go through as well. So just starting off, normally I would start off with the options, going through the through layout of the system. This is SolidWorks 2018, and so just quickly looking at the options, everything that we would never want to know about SolidWorks is buried in there somewhere. File, latest and greatest models that we've been working on, and the toolbars. Since nothing is open, we don't have very much. If you're not seeing that bar, it's because the push pin isn't in effect. So we'll stay with the push pin. I do like to have those pull downs available without messing around with the flyout. Going through the search commands, right now we're there's something I was looking for. I could type it in and pull it up. Our screen, maximize, minimize, and then span dual monitors, since I have dual monitors on this setup. The task pane, things that are available. Our work area, the system bar, which looks like I need to adjust just a little bit here into my view frame, and then this system bar at the bottom. So let's go into a new. Our part was in inches, so I'm going to stay with the templates that we've used. We'll keep the icons big so that you can kind of see those on the command manager, and then the tabs. We're currently not using weldments, probably not dim expert, so I'll turn those off just to open up a little more room, get my heads up, the icons across the top a little bit tighter to the command manager. Over on the left, our feature tree, and of course the blue origin is telling me short leg horizontal, long leg vertical, and it's in blue, so it's currently waiting for me to do something. So front plane, not critical that we make our models look exactly like the drawings as far as orientation, position, those types of things. What is critical for us is going to be getting geometry tied to the origin. And so once I'm in the sketch, I can click on sketch, would select the front plane. I'm going to stay right with my my habit of right clicking on the plane that I want to start with. Go into the front, and for sketching, I may click and drag. So I'm going to build out the geometry. On the next one, I'll do the click, but I found that click drag works the best for me. So 1.5 inches. If we just put dimensions on everything, we're building in design intent that this may change. That there is something that I may need to adjust for. I'm going to use the dimensions in the drawing that we took a look at a while ago, and we're just going to do a straight extrusion of also 1.5 inches. Now I haven't set up a folder to save these, so we'll go File, Save As. Went to my Dropbox, so new folder. And give them a location. And part P4-1. Okay, and that's pretty much all there is to it. And if this was going into an assembly, we'd go into that next process. If we were going to just make one of these, we'd take it directly into the drawing and start detailing. All right, so not that I ever pay too much attention to instructions, but in this case we will draw a front, top, right side orthographic view of each of the objects and figures P4, 1 through 494. Well, the drawing portion of it would be to send this over to make drawing from part is one way. And let's go with the template, or the default template, which will ask you. And this is going to my location, so I can't pull up the default. I'm going to have to browse back to that. Well, let's just go with a blank sheet. All right, and then the view palette comes up automatically. Normally you would see, since I redirected this and apparently did not also include the other setup, the default setup sheets, normally you would see the A landscape, A portrait, and all of the ISOs. So if we're going to do a front, top, and right side of our object, and go into the projected view. Thought that was turned on, but maybe not. And that will give us our 3 views. All right, and then we would go ahead and dimension. And I haven't set it up any layers or gone any further, so other than to make sure that my dimensions were turned off. Okay, and kind of the general rule is that if you don't need dimensions on a view, you probably don't need the view. So we'll put a dimension on just to retain that view. And you know, pretty much like it looks like third angle projection. I want to say the last 3 or 4 items in this chapter they put in first angle projection, which is occasionally seen, or at least good to understand the process. But for third angle projection, if we were to take this sheet and fold it over to the back, we would have this view. And if we were to fold it horizontally and over the top, we would have this view being looking down on the isometric. So that gives us our 3 views and enough dimensions to make the part. We don't have anything on this blank sheet for material, finishes, other pieces of information that'll be useful in the manufacture. So let's go ahead and save this. This is going to stay P4-1. Some of the more interesting pieces I may go ahead and do detailed drawings on. I'll stay with the new. Next piece is in millimeters, so I'm going to go over to my metric template. And we'll stay with the front plane, open the sketch, go into the line, and now the click is to click, let go of the left mouse button, and we'll get a roughly 40 millimeter, and so P4-2 flashed up a little earlier. It's basically another step block. And clicking allows it to be continuous. Trying to think of where the advantages are to the click drag, but I think they'll kind of pop out, and you'll find your own preference in the workflow. All right, throw some dimensions on this. All right, still staying with the design intent that we're going to just build in basic geometry. There's nothing here that we are going to start in on the relations with just yet. All right, and then depth of 40. So our 2 blocks. And we'll go ahead and save. And the only thing about reusing the previous name is that if I happen to hit save, I just overwrote my part and lost it. So be careful with that technique. All right, so let's fly the PDF back in. Again, this is engineering, design, and graphics with Solidworks from the 2014 book. And if you've watched any of the other videos, you've heard me say I like this book because it does have some mistakes and it has enough information going through the chapter text to get you started and in the headed in the right direction. And then you do need to pay attention and look at your geometry as you're going through. There are some missing dimensions and some geometry that doesn't quite work out, which is nice to be more of a real-world situation. So P4-3 is in millimeters. Looking at this, we'll do a couple of stair steps. I don't know that it needs too much, so stay with the new. Part metric, we'll go to the front plane. And throughout the fall semester, the 2017 fall semester, I took kind of where I could, some unconventional tracks to show you the capabilities. And at least the first part of this group, I want to keep it fairly straightforward. So we're going to stay with the dimensions, basic sketching, get into more of the layouts and working with the geometry a little later. All right, so 25 and 40 across the top. All right, so this can extrude out, and we have a depth of 10. Open up a new sketch. So just right-clicking on that face, open up the sketch, building on to my next piece of geometry. I still like the convert entities, so one nice thing about convert entities, it pulls those edges in, and even though it shows fully defined on that endpoint, I can drag it back, and as long as I don't mess with it, it'll stay fully defined. But if I move it, then I have to put some relation or dimension on it to get it back to being fully defined. So dimension of 30, dimension of 15. All right, so let's see, was the top. So I was going to say, looks like it's fairly even there. No detail dimension across that face, so 15 would be a safe assumption. But without a dimension there, it's a little bit suspect. All right, so our first relation then will be to set those two items to equal. All right, if I find out it's not equal later on, that it was 10 millimeters, the thickness of the back, then I would come in, locate my equal length or equal length, and delete that relation and apply the dimension or modify the geometry as needed for the correction. All right, and then overall length was 30, so this comes out an additional 20. And that'll generate my shape. So P4-3. All right, 4-4 was in chapter 1, or at least looks familiar. The next 2 or 3 look familiar. So we're going to, I will treat this one just a little different in that the previous times we've done this, we've built the block in stages. This time I'm going to do it as if it was subtractive. All right, so what we've done so far is we add geometry as we go. And let's see, this was in inches. And the advantage is speed, that we can add a piece of geometry, add another piece of geometry, keep it going. The subtractive portion would be helpful if we were going to detail the manufacturing process. So I'm going to start off with the full size of material, 2.5 by 3 by 2.5. Okay, so we start off with that block. And looking at this from a manufacturing standpoint, I would probably, in a manual environment, I would square up this block to size. And then I would take the steps, and we could, let's go ahead and open up the sketch on this face. And we have a depth of, well, coming up from the top, I'll have to do the math. 0.75 plus 0.5, and then we're 1.5 inches back, and that's going to be an extruded cut all the way through. Okay, from the other side then, and I could put in the dimension again, but I could also jump over to, and I've added it to my my box, is the hidden lines visible, rather than going to the pull down all the time. And we'll drag that to be close, and then the edge I'll make coincident. So those will retain the same height now. And did not need a fully defined, an over-defined dimension there, so I'm just going to Control Z out of it and go back into the dimension command. And then this becomes an extrude cut, also through all. Alright, so go back into Control 7, isometric. We can switch back to shaded. Alright, so shaded with edges, shaded without edges, hidden lines removed, hidden lines visible, and all lines. Oops. Alright, so everything as a wireframe. Alright, so even when you're looking at it in wireframe, you're getting a better view or different view of the geometry, but it is still a solid. Alright, so the next step in my my process, let's go ahead and open up a sketch on the back side again. And this was 0.75. And let's see which side I'm looking at here. So there are two different heights. So 0.5, 0.75, and then it reverses on the other one. Okay, so that gets a double click and gets switched back to 0.5. And then the depth. Now we have a missing dimension that if that's 2, that's 3, and then kind of looks like about halfway. So that would be one of those suspect dimensions, but if we go a ½ inch deep, that'll give us a decent start. And through all. Okay, coming around the other side, then ½ inch by ½ inch. Since we're not sure of that number, I'm hesitant to make the two edges equal. And I didn't quite go with the dimension, but we got it in there. And then from the bottom, and again, I kind of lost my perspective, so I'll go with the hidden lines removed. Make sure that I'm not interfering with the large boss. And we had 2 inches and 1.5 inches. And then that becomes an extrude cut through all as well. Alright, back to isometric, back to shaded with edges, and we have the shape. So the advantage of doing this is I can come over here, grab the rollback bar. We can start with our cube and step through. My first cut is to take material off of the side. If I was set up in a mill, I could bring the end mill across until that material is removed. And then in the same setup, come across until that material is removed. Remove the next step, all while holding on to the vise with the vise jaws kind of level here because I've already squared up the stock. And then come across with the end mill and do the next step. And then the last would be to rotate the part over in the vise to where I could hold on to it and remove this material. So I could go through a process of how to create or the preferred methods for this manufacture. If I decided that I wanted to do that item first, and got a little bit ahead of myself. All right, so there was one relation, or two relations. All right, but as we go through, whatever got removed off of that face, we could go back and pick up. So as long as you're careful, that's pretty much what those arrows are telling me, that there's a relation back to. But because I've changed the geometry related to that face, basically this face was modified, there's going to be an issue with that sketch now. And so it may not have a direct parent-child relation back to Cut Extrude 1, but the sketch plane that is created here certainly will. All right, so we'll get into more of that a little bit later, but history-based is we can't put the parent before the child without losing some of the relations or breaking some of the relations to modify that geometry. So let's go ahead and save this. 4-4. All right, flying in for 4-5, block with material. We could do this as an offset or a thin feature. So let's see, this one's 15, 15, 16, 40. Don't really have a dimension there, so. All right, so in this one, 10 millimeters, 10 millimeters. Aside from the step is 15 millimeters. All right, so this one's not going to be a candidate for a thin feature because we have one dimension that is off. Maybe could do the offset for 2 sides, 3 sides. So instead of doing the file new, on this one I'll come to the menu bar and go to new. We'll stay with the front plane. And up until now, we've always related to the origin at one of the corners. So if I wanted it, in this case, for the midpoint, I'm going to select, hold down the control button and select the line. Select the origin, hold down the control button, select the line, and then in the pop-up I will get a midpoint relation. So we're going to go ahead and draw the outside, and then it jumped over, hit L on the keyboard to get back into the line command. Select control, select the lines, and we can make those collinear. That has the same net effect as selecting an endpoint and control selecting a line and making them coincident. All right, mainly that when this moves, they move together. All right, so overall dimension was 80. Overall height is 40. 30 in 2 places. Okay, so since it's 2 places, we can make those equal. And then let's go for the offset. We have 10 millimeters all the way around. Yep, just double checking here. So 10 millimeters, 10 millimeters, 10 millimeters, and then the one oddball 15 millimeter. All right, so in this case, I'm going to leave out this line. We're going to go offset entities. 10 millimeter comes up. It picked the chain, so I want to turn off the chain. And that one kind of jumped out the wrong way, so we're going to go ahead and remove that from the set. So at this case, it's looking about like it would have been as easy just to go ahead and do the sketch. All right, so I got to watch capping the ends because it also put, this kind of, yellow highlight, and it's going to put one at the opposite end. All right, so that gives me my geometry. And just like the convert entities, I can pull that line back. Usually it'll leave a point out here somewhere. But we'll draw in the rest of our geometry and cap those off. All right, so our 15 millimeters goes in. our collinear, well, let's do the coincident thing. So endpoint and line becomes coincident. Features extrude, since we went to the midpoint, my design intent is kind of shifted to being at the bottom center of the part. So on our directions, I can go midplane, and we have an overall of 40. Okay, and then the 15 millimeter side gets a rectangle. All right, and if we do this math, 15 and 10, 15 would be pretty well centered. All right, so design intent says if that's going to be centered, then I can right click, select midpoint, hold down the control button, select my edge, and go midpoint to midpoint. Dimension then is 10 millimeters, and the depth is 20 millimeters. All right, Control 7, back to isometric, features, extrude cut, and we'll just give it an up to next. All right, so if I go up to next, it's going to find that interior wall, as opposed to through all, that's going to go all the way through the face, as opposed to up to vertex, which we can then pick. All right, and if there was something there to pick, but basically we're giving it the different end conditions. Up to surface, and not really anything that we can do with offset or up to body. So let's just stay with up to next, but quick view of what you can do with the end conditions. All right, so we'll give it a Control Save. P4-5. Next one also in millimeters, new, part metric. And so this one is 15 millimeters all the way around. This one we can go thin features. So I'm going to put the origin on the bottom. Okay, and then I come back and I change my mind and say, well, you know, I've got this coincident relation to the origin. I can delete it. And if we put in our dimensions out here in space somewhere, okay, so 40 overall, 70 for the height, 60 on the length. Then at that point, the sketch is free to move. All right, until I bring it to a relation, coincident relation to the origin, or put some dimensions back to the origin, it's going to remain underdefined. All right, and the advantage of an underdefined or a defined sketch is that it doesn't shift accidentally. There's no accidental change of dimensions or change of location. All right, so I want to offset this one. Oh, we said thin features, sorry. If I offset this, we're going to go 15 all the way around. If we go into the features, everything has to have the same wall thickness, but we can go extrude. It's going to default to thin feature. The checkbox is grayed out. You can't deselect it because this is now an open profile. All right, blind in condition is to 50 millimeters. And we'll let it come out forward. And one direction is midplane, two directions. And we have 15 millimeters. So then I want to look at this from the front real quick and make sure I drew the outside profile. So we're going to reverse that that thin feature geometry to the interior. Okay, so one block through the center. And 15, 20, and another 15 will add up to 50. So again, centered on the piece. And if I go midpoint and select midpoint, we can go midpoints. Nope. So since that's not a viable option, I'll go with the center line and just make it vertical. All right, I could put a point there, but I don't think it's as visually makes as much sense. All right, 25, 20, and we have 20 on the width. Extrude cut. Up to next, that could be a through all because it's not going to interfere, but on the off chance that the geometry changed, we wouldn't want it to find its way past that mark. All right, so what I was trying to do before, select midpoint, hold down the control button, select midpoint. Notice that that midpoint jumps away. So I can't just make midpoints horizontal. If we were to do a point, I could put a point at that midpoint, make those points horizontal, but by the time I do all that, it's easier just to draw the center line, search for my midpoint icon. All right, so the reference pops up. That center line becomes horizontal. And then the geometry, we're 15 deep. 15 on the cut and 20 on the width. All right, so since the 20 on the width matches the other geometry, I could use that, but we'll go ahead and do an extrude cut. And if I do a through all, notice that the preview shows the intersection. So in this case, we'll need to do an up to next. All right. So one of the considerations in the manufacture of this part is we're 45 millimeters, so not quite 2 inches. That's a little deep. We could get these square corners in and remove that geometry. What is going to be an issue, especially on this this face, is these square corners. If I can put even a minimal amount of radius in there, it's going to help with the manufacturing process. We're going to be able to wire EDM, leave maybe 5/1000ths of radius in the corner for the wire, but wiring this, just like we saw the extrude cutting into this base material, the wire is going to do the same thing. It's going to try and come around. So being that this is 15 millimeters, which is about 590, so call it 600,000ths deep, even putting an 1/8 inch radius in there, 1/4 inch would have no problem. A 1/16 would be a little bit of a challenge, but doable, and increase the manufacturability of the part by quite a bit. All right, B4-6, and we'll go ahead and save. All right, so I'm going to try to keep these in half-hour segments and see how far we get with each of these groups. So end of segment 1.